Hello, everyone. Today we're gonna do a tree problem, easy problem, not too bad. It's gonna be a path sum, and so this is very intuitive and very self-explanatory because it's like in the definition of leaf nodes and understanding the sum towards adding up the sum for a target sum. Anyways, so the problem is given the root node of a binary tree and an integer target sum, so that's the parameter that's going inside target sum. Return true if the tree has a root to leaf path target that adds up all the sums. So in this example, we have five. We have all these, let's just say we have all these nodes here. And like a user just inputted 22 as their target sum. And we could check all these paths to check if the value of all of those could be 22. And so we could check 5, 4, 11, 7. Adding up all those are like probably like 26 or something. Like that's not 22. So we check the next one. Like you could check the left one, but we're just gonna check the right side just to make sure like it's not adding up to 22. It's 5, 8, 4, and 1. That's not 22. And then also like what I'm trying to say is that when I'm adding up all these nodes, they stop at the leaf node. So this would be a leaf node because it doesn't have any children. So yeah, it has zero children, so it's a leaf node. So 5, 8, and 13 now. But when I can recursively call everything, and it's the last one would be 5, 4, 11, and 2, and it will return true because that's the sum that we're adding up, and that's all it's asking for. So we're gonna code that up very, very shortly. I was coding it before and it wasn't. Anyway, so our first condition is just going to be if the root equals null. And for here, it's saying just return true or false. That's what it's saying. So I'm going to say if root is null, return false. That's step one. So if root equals null, we just want to return false because there's nothing in there. So return false. Okay, but then we wanted the next condition would be not the recursive call itself, it would be once it has reached the target sum, right? So else if, I'll just say target sum acquired. Let me think about this. Else if, so if, okay, so we want to check if those two left and right are not, are, no, they are null because they're empty. So we'll say else if root dot left equals null, and then root dot right equals null. See, they're empty, and I don't think they would be or. They would be and because we have to make sure they're both empty. So, and this one would be, we would apply the target sum. So target sum target sum minus, it's like calculating k of something. So we want to say target sum minus the value they're currently at. So root dot value equals 0. That means it's target acquired. So return true. And the next part is when we actually do the recursive calls. Else, and then we want to say return. What I like to do for recursive path, recursive call. Sorry, what am I doing? Recursive calls are just copy this and just change the parameters that we're implementing. So has path. We want to say root dot left. Return has path. Root dot left. Root dot left. Sorry, and then target it has path root dot left target sum minus root dot val And then the other one would be the right side. No, as path root dot right to sum minus the value that we're currently at. And this should be the answer. That's fine. Because that's the recursive call. Yeah, this should be the solution. Like, I think it makes sense, to be honest, because at the end of the day, you're just returning each time you're recursively calling like left, right. And if it's actually at the path, then it's 0. And then, yeah, so that should be very simple. Very simple, beats 100%. Yeah, that's my solution to this problem. Yeah, thank you guys.